All right, let's take a look at lesson 10.3. Problem number 1 in the Bellringer. It says this. A stadium has 25 rows of seats. The third row has 260 seats, the fourth row has 265 seats, and the fifth row has 270 seats, and so on. What is the total number of seats in the stadium? So the first thing I want to address is, what are we actually solving? And here in the last sentence, we see we're trying to find the total number of seats. The total number of seats, which the total is a synonym for the word sum. Or as we learned in lesson 10.1, we could find this with sigma, the sum symbol. Now let's label some things. We have 25 rows of seats, and it says here the third row has 260 seats. So that's the easiest one, I think, to figure out what everything represents. That if A3 equals 260, because it's the third row, then here's what I can establish. I can establish one, that the little number there, that's the row, and the larger number would refer to the seats. So in the first sentence, when it says a stadium has 25 rows of seats, since that's a row, that would be talking about the little bitty number. Like there would be up to A25, or said another way, A25 would represent the last term, AN, and therefore N would equal 25. Now, going on, it says the fourth row has 265. So let me just write this out. A3 is 260. A4, whoops. A4, sorry about that. Here we go. A4 is 265. And now A5 is 270. And I can see that these are increasing each time by the number 5. Hopefully that's kind of obvious to you, but if it's not, we learned in lesson 10.2 that you can find what's called the common difference by taking the second term, or really any term. Let me erase that 2 because it can be any term. In this case, it's not the second first. Any term and subtracting the term that came before it. So, or said another way, we could take 265, term number 4, this one, and subtract term number 1 that came before, excuse me, term number 3. And I can subtract that and find out that the difference is in fact 5. Now, how do we solve it? Well, what I'm going to first do is go over to our formula chart. I'm going to take the algebra approach. So from your digital classroom, if you click on the formula chart, so that's lesson 10.2. Let's see, 10.3, what we're on. You can click formula chart right there. I'm not sure if this will let me write. It won't. But you can click formula chart, and it should open up a window like, well, let's see here. Where is it? There it is, formula chart. And if I go down, I'm looking at the nth term of an arithmetic sequence, which again, it's not letting me write, unfortunately, but it's this formula here that's kind of being highlighted. That's the formula we're going to use. But to find a sum, they're going to change one thing. So if this is the formula says sigma. No. It didn't say sigma. The formula said AN equals A1 plus N minus 1 times D, which we talked about the N's corresponding as well as the 1's corresponding. What I'm going to do for sum is I'm going to replace the AN equals with sigma. You start with N equals 1, and you go up to however many number N's there are. And then we will substitute in here, A1 plus N minus 1 times D. And again, if you don't have the first term, that's okay. The 1's correspond. So in this case, we don't have A1. However, we do know that we do have A3. So if that's going to become A3, this needs to be N minus 3. So, whoops. One other thing to note before we do this in the calculator, with sigma, you never replace N. Never replace N when using sigma. Okay, so what I will type in here for the calculator is we will type in the sigma, or the sum. N equals 1. There's 25 rows we got earlier. 25 rows of the third term, which would be 260 plus N minus 3 times the common difference of 5. That would be what you type in the calculator. I'm going to let you do this on your own. You can go to the calculator and do that. You can go to Desmos and type that in just on a blank graph if you want. If you type that in, you'll get the solution there. Now, I did say we were going to use a calculator as well. And so I do want to remind you that if you were doing this without doing all the algebra, you could. That's the calculator for this new lesson, not the one for, okay, let me open up Arithmetic. Again, this is listed on the PowerSchool Learning. But you could type in here, the first value they gave us was 260, but it was the third term. So you'd say t is 3. That's saying that the third term, at, where t is 3, so a3 is 260. And you'd put in the last term here, which we don't know the last term. So that would be an x. But we do know there's going to be 25 of them. And the common difference was 5. Now, if you did that and you zoomed out, what the calculator would find, the first value that it finds at the intersection is the last term, because that was what was missing from up here on this line right there. That intersection would be finding the last term, that 370. And if you type that in, you could get your summation right there. So that's how you could do number 1. Let's take a look now at number 2. It says arithmetic series is shown. 3 plus 8 plus dot 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 plus 33 plus 38. Which of the following summations accurately describe the series? Well, again, one of the things I can observe really fast is I can see, because these are simple numbers, that this is increasing by 5 here and by 5 here. So I can go ahead and state confidently that my common difference needs to be 5. But when I look at the problem, it wants us to represent that series in sigma notation. And so one of the things you could do is you could type these in, but I want to remind you that the sigma finds the sum. So the calculator won't exactly tell us the one and only answer, because it'll just tell us the sum. But I could still type them in. Let's see how well I remember these. So to type in the first, you can just type in SUM for the keyboard, SUM. Or you could have also gone to functions on the right side and gone to miscellaneous tab, and it's there at the bottom center. Anyway, we could type this in. I think the calculator had K, or the problem, not the calculator, it had K, and I believe it was from 3 to 10. The lower bound of 3, whoops. This isn't up to 10, there's the upper bound. Let's see if it'll give me the lower bound again, 3. And I believe the first one was 5K minus 12, 5K minus 12. So there's our first value. And the next one was very similar, but it was 0 to 7. I do remember that. Now I'm going to have to go back over and see the problem again. It was 0 to 7. I did notice that. 0 to 7. And let's see what the equation was for the second. It looks like it's 5K plus 3. I'm looking right here at number 2. 5K plus 3. So 5K plus 3. Notice again, I get the same answer. So those two very likely might be true at the same time, or both false together at the same time. The last one, I did see it had the K values from 0 to 8, and I think it was 5K minus 2. I'm going to double check. I believe that's what it was, 5K minus 2. It is. Number 3 is 5K minus 2. So you can see that one's a different answer. So either way, the third cannot be true, and also the first or second be true. It'll go, whoops, little picture of my family there. This sum right here is going to equal 162. And this one's 164. And this one's 164. So truthfully, if we find that one of them is true, we could eliminate the other going through there. So anyways, how does this work? Well, this is a process question. So here's the process for sigma. Process. And the process is to find your first term, you plug in the lower bound, which is the lowest K value. So on the first example, I would type 5 times the lower bound of 3. Again, this is the lower bound, to remind you. Whereas the top number is called the upper bound. And off to the right of sigma, that's the equation right there. So what you do is you plug the lower bound into the equation. So I'd have 5 times 3 minus 12. Well, 5 times 3, if we do a little mental math, that's 15. We subtract 12, I'm getting 3. Which is exactly what it was supposed to be. So that's good. Let's try the second option here. Let's try this one. Series number 2 that's listed. If we plug in a 0, so the first term would be plugging in a K value of 0. Also now this time we have 5 times 0, which is 0 plus 3. Again, I'm getting 3, and that's what it's supposed to equal. So that's good. Now let's try our last sequence here. If I plug in the lower bound of 0, 5 times 0 again is 0. I subtract 2, I get -2. Is that what it's supposed to be? No. So that sequence is out, or that sigma is out. That is not going to describe the series. So now I know it's going to be at least one of the first two, if not both. What you can do, once you know, if you know the first one's going to work out, test and see if the last one will work out. So the symbol, let me erase and say I'm skipping some. So I'm going to go dot, dot, dot. I'm skipping some here, and I'm going to the very last one, which we can symbolize by an. What you do is you plug in the upper bound. So the upper bound on the first sigma is 10. So I'd say 5 times 10 minus 12. Well, 5 times 10 is 50. Subtract 12, I'm getting 38. That's exactly what it's supposed to be. So that's good. If I check my second sigma, whoops, an, not a2, an, I'd be plugging in the upper bound, which is 7. 5 times 7 is 35. Plus 30 equals 38. Exactly what it's supposed to equal. So it appears that both the first and the second are true. These are good, whereas number 3 is false. So 1 and 2 are true. All right, so that was a review of lesson 10.1 and 10.2. Now let's take a look at lesson 10.3, geometric sequences and series. So the first thing that's different is we have a different formula. So going over the formula chart, the formula we're going to use today is shown here. Let's see if it'll highlight it. There it is. An equals a1 times r to the power of n minus 1. I'm going to go ahead and write that down. An equals a1 times r to the power of n minus 1. And once again, I want you to make the mental note that the ones correspond to one another. Those correspond. So you don't have to have the first term. You could use the third term and then have an n minus 3, or the 10th term and n minus 10. That would work. As well as not only do those correspond, but the n's correspond. So that'll be very helpful to us in our problems. All right, so let's now take a look at lesson 10.3. So first it says, determine the common ratio and find the next 3 terms of the geometric sequence. So the first thing that's helpful to know, if on arithmetic series, for arithmetic, oops, sorry, let me just erase this. Arithmetic, a little dyslexic there. The common difference was the second term divided minus the first term, or said another way, any term subtracting the term that came before it. Well, for geometric, what we're dealing with today, they call it a common ratio, and the common ratio is found by saying you take any term and you divide it by the term that came before it. So say it another way, whereas last class it was a2, that's not a 2, a2 minus a1, a2 minus a1. Today what it'll be is a2 divided by a1. a2 divided by a1. So let's take a look at part A. It says, find the common ratio in the next 3 terms of this geometric sequence. So the first thing I need to do is find my r value. So r is going to equal 9 divided by -6, which we could type that in the calculator, but I know that that is -1.5 or -3/2. Since they're using decimals, I'm going to go ahead and use decimals. So that's what that means. What we're doing here is this is multiplying by -1.5. That's getting multiplied by -1.5. So we need to find the next 3 terms for the sequence. And so the next 3 terms, so a4 would equal -13.5 times -1.5. And I'm going to go ahead and find out what these all 3 are in Desmos. So let me just get a blank graph here. New blank graph. There we go. So I have a -13.5, and I'm multiplying that by -1.5. So that'd be my first term. And then I would take that term, 20.25, I'm sorry, and I'd multiply that by -1.5. That'd be the third term. And do I only need to find, how many more? I need to find the next 3 terms. So we found 20.5, we found negative 30.375, and now I need to find one more, negative 30.375 times negative 1.5. And I get 45.5625. So those would be my terms there. So we had 20.25. Let's see how good my memory is here. And then 20.25 times negative 1.5 gave us 30.3, was it 3725? My memory's failing. Let's take a look. Negative 30.375. Negative 30.375. And then finally, our sixth term, it was negative 30.375 multiplied times negative 1.5. And I believe that one was 45.5625. I believe that's what it was. So that would be the next three terms right there. And let's see if I set that over. There we go. That would be your next three terms. Okay, now let's try part B. Now part B tries to get more complex. I want you to notice that this is a sequence, and review terminology there. If it's a sequence, it's separated by commas, which means this whole thing right there is A1. This whole thing is A2. This whole group would be A3. And again, we're going to find the next three terms. So what I'm first do is find my common ratio. So I'll take the second term, negative 81n plus 243, and I'm going to divide that by the first term, 243n minus 729. So a little math rule, if you remember this from chapter 2, if I want to simplify a fraction, I can't just say, oh, 243, 243, cancel, cancel. That doesn't work because they're not factors. So I need to factor this out. On the numerator, I think 81 will go into both numbers. And since the front number is negative, I'm actually going to factor out a negative 81. And so that would give me n, I want to make sure, 243 divided by 81. Come on now. 243 divided by negative 81. And it is negative 3. Perfect. So this will become n minus 3. What I just did there, we call it GCF, greatest common factor, but it's the opposite of distribution. Now, instead of multiplying through the distribution like we normally do, we would normally multiply like that. I did the opposite. I created distribution. Okay, so let me go back now to the denominator. It looks like to me 243 will probably go into both numbers, which will leave us n, and let's see, negative 729 divided by 243. Negative 729 divided by 243. And I get negative 3 again. Well, that's nice, because now what that means is I have a common factor. And we're allowed to cancel those because they're factors. And so that means however negative 81 over 243 reduces is my common ratio. So one more time, negative 81 divided by 243. And I'm going to change this to a fraction by pressing the blue button. It's negative 1/3. Negative 1/3. Now I could change this to a decimal, but I'd prefer to leave it this way. So to find my fourth term, what I would do is I would take my third term, which is 27n minus 81, and I'd multiply all of that by negative 1/3. And I'm going to just do a little quick mental math here rather than going back and forth to the calculator. 27 times the negative 1/3 is like saying 27 times negative 1, which is negative 27, but then dividing it by 3, which I get negative 9. There's n there. And then the negative 81 multiplied times negative 1 would be a positive 81. Divide that by 3, we get a positive 27. So that's my fourth term. So to find the fifth term, I would take that value, negative 9n plus 27. Let me fix that 7. 27. And I'm going to multiply that times negative 1/3. And we get, let's see here, negative 9 times negative 1/3 is going to be a positive 3. And there's an n there. And then positive 27 multiplied times negative 1/3 is negative 9. And finally, the sixth term and the final term. You take that 3n minus 9, and we're going to multiply that times negative 1/3. And lo and behold, let's see what we get. 3 times negative 1/3 is negative 1. So just negative n, negative 1n. And then I would have plus 3. And so these would be my values right here. That would be terms 4, 5, and 6. Now, here is yours. You can pause this video, is what I suggest here. Just pause this video, work out the problems. Remember, your ratio is determined by taking the second term, or really any term, and then dividing by the term that came before it. So do that first to find your ratio, and then from there, multiply that ratio through. Pause the video until you're ready to move on. All right, let's take a look at example 2. So example 2 gives us that formula. This is the exact formula right here. It's found in the formula chart. AN equals A1 times R to the power of n minus 1. They do not use a parentheses. I do, just to keep track of things. But like the note said earlier, I want you to remember that the ones correspond. So if 1 is no longer a 1, it becomes a 2 or a 3 or a 4, so does the other one. And the n's correspond. So what's n on one side is going to be n on the other. That is found on the formula chart, as well as the Desmos calculator, which I do have a geometric calculator. So it says write an explicit formula and a recursive formula for finding the nth term in the sequence. So what I'm going to first do here is I'm just going to divide my page. And we'll first find, because it says the explicit first, I'm going to find my explicit formula. So this is using the formula chart. AN equals A1 times the R to the power of n minus 1. And so for this value, I can tell the -1 is A1. And we could find our R by saying it's 2 divided by -1. Those are easy numbers. 2 divided by -1 is -1. So my equation is going to be simple plug in. A1 is -1. R is, why did I put -1 on my ratio? Need y'all there to correct me. Okay, -2, there we go. So -2, all this raised to the power of n minus 1. You could actually simplify this if you wanted to. You don't have to have a -1. You could just change it to a negative, like that. You could write your answer in that format. Now, what I will point out about this is you cannot distribute that 1 inside of that parentheses. You cannot do that. And distribute and eliminate both negatives because the -2 has a power. So that wouldn't actually work. So you would need to just leave it like so. Now that's the explicit. And it wouldn't be the worst thing in the world if you just pause the video and try it on your DOL to first find the explicit. You might want to pause it right here and try to find your explicit. Okay, I'm going to go backwards now and find the recursive. So going back to the previous problem, to find the recursive, there's 3 steps. Step 1. What you will do is you will state A1. I'm going to put in red what could change. Okay, step 2. You will state the value. It's technically this. It's technically AN equals AN minus 1 times R. But because of where we're going to be plugging in values, the way it'll always simplify is we'll end up having the R in the front. So I'm going to go ahead just for here. The R is what you'll substitute. So we'll put that in red. R. And then I'll put after AN minus 1. You'll take the ratio and just multiply it times the previous term. And then finally, step 3. This will not change. So I'm going to do it all in blue. You'll write this is true for n greater than or equal to 2. That means to find the second term or any following, you would follow that pattern. So in this particular problem, my first step, I would state A1 equals -1. I would say that AN will equal, my ratio is -2. -2 times the previous term, which then needs to be an A, not a parenthesis. Let me change that. Let me fix it. -2, that's my ratio, times the previous term. And this is true for n greater than or equal to 2. And that would be my solution there. All 3 parts together. Okay, with that, I will let you try example number 3. Or the DOL number 2, I'm sorry. DOL number 2, again, this first portion is the explicit. And this portion over here are the 3 steps of recursive. Pause the video until you're ready to go. All right, example 3. So now let's get into the fun stuff. So finding the nth term. To find the nth term, what we're going to use is that formula from the formula chart. If you're in class, you should have this formula chart. If you look on sequences and series, I'm using the nth term of the geometric series. Like, I wish it would let me highlight the whole thing, but it is what it is. It's just letting me highlight some, not all. But that's where I'm looking. The an equals a1 times the rate raised to the power of n minus 1. That's the formula I'm going to use. If you're going to use algebra, a1, and I put the rate in parentheses, to the power of n minus 1. That's what I'm going to use. So in this problem, it asks me to find the 11th term. So the 11th term we could symbolize as A11. They've also given me, that would be A1. So as soon as I see that that's A1, then A11 is going to be my AN, which means n will equal 11 because that's the last term they give me. We also need to find a ratio. So I'm going to take the second term, 115.9, and divide that by negative 122 to see what that value is. Calculator, let me clear off some of this. Negative 115.9, negative 115.9 divided by 122, I believe were my numbers. I got the negatives backwards, but it actually, with one negative, it doesn't matter. My value will be negative 0.95. Negative 0.95. And again, since they're using decimals on this problem, I'm going to list mine as a decimal, as opposed to if you change it to a fraction, that's negative 19/20. I'm going to leave it in this form. So how do I find the 11th term? Well, I plug in my values. AN is going to be A11. A11 would equal the first number, negative 122, times the ratio, negative 0.95, raised to the power of n's 11. 11 minus 1. So that's where all my values came from here. As you can see going through, I just substituted in. If I type that in the calculator, it should get my answer. Since the value we're looking for is isolated, I could just type in the rest. So it'd be negative 122, parentheses, negative 0.95, raised to the power of, and be careful on the powers. If I do 11 minus 1, that minus 1 won't stay in the power. You either need to do a parenthesis or subtract it yourself. So I'll just do a parenthesis here. 11 minus 1. And my answer should be, wow, negative 73 point. I'm going to round this to the nearest, let's call it 1,000, 3 decimal places, because 1,000 has 3 zeros. So negative 73.04, that 9 is going to round up, so it'll be 046. Negative 73.046. And that would be my solution. Now you might be thinking, do we have a calculator for this? I don't like this algebra. Well, yes, we do. Let's take a look. Again, you can go to the calculator list. Since I'm doing this off of iPad, I'm just going to pull it from my list straight from here. I think it'll be easier for me. If I can find it, there it is, geometric sequences and series. We had the first term as negative 122, the very first term. And since it's the first term, I have t equals 1. The last term we did not know. That's what we were looking for. But we do know it's the 11th. R we got by taking 115.9 and dividing that by negative 122. So when I zoom out, this would solve for my unknown. There it is. Negative 73.046, exactly what we got. So that's great. We did it correctly. So that's how you would use my calculator. And I guess I should have, for the sake of the calculator, the first term goes as AT, with t equaling 1, so this is the first term. The last term would be AN, as I have written up top, and 11, and AN would be unknown, and then the ratio we already had. Okay, so with that, I'm going to let you try DOL number 3. You can either use my calculator or you can use the algebra. But pause the video until you're ready to move on. All right, let's take a look at a real world example. It says real estate. A couple purchased a home for $225,000. At the end of each year, the value of the home appreciates by 3%. I'm going to pause here. Appreciate. When you see the word appreciate, what that means is it grows from being stable, and being stable is 100%. So appreciate, what appreciate means is 100% plus the rate. For the record, depreciate, if you saw that, would be kind of like the opposite. If it loses value, this would be 100% minus the rate if you saw depreciate. So I'm going to just give you that note. It says now, write an explicit formula for the value of the home after n years. Now remember our formula. Again, I could go back and forth, but I don't want to make you dizzy switching between apps. So the formula, I'm just going to quote it to you, is AN equals A1 times R to the power of n minus 1. And now note, remember how we said these correspond. Okay, so why do I point that out? On this problem, we buy a home and we don't buy it in year 1. When we buy, we purchase on year 0. Purchase in year 0. So what does that mean for my formula? My formula is going to be that A n, the value of the home, will equal A0 times R to the power of n minus 0. We also have the appreciate. So we're 100% plus 3%, which is equal to 103%. Or if you divide that by 100, 1.03. So what does that mean for our problem? We plug in our values. We don't know AN. We do know the original cost of the house is $225,000 times the rate of 1.03 to the power of n. That's plugging in the A0 and the rate. That would be my formula there. And it would also find the value after that many years. After n years, I should say. So let's see what part B has to tell us. Part B wants to know what's the value after the home after 10 years. So I'm going to go ahead and copy down the value of the formula again. It was 225,000 times 1.03 to the power of n. So if I want to know the value of the home in year 10, I would take the 225, which is the original amount, year 0, times 1.03 to the raised to the power of 10. I don't know if I've really made that clear. The reason I put in a 0 is because when you buy a home, you don't buy it in year 1, you buy it in year 0. And so that's why the 1s got substituted from the original formula to 0s. Okay, so that's what I need to type in my calculator here to get the actual amount. I'm just going to get a blank line. That's not right. There we go. $225,000. Since my unknown's by itself, I don't have to type that in. Times 1.03. All this raised to the power of 10. Whoops. 10. Take away that 0. And it's $302,381. And if I round, 19 pennies, because that 5 would round up. So 302, 381, 19. We'll do squigglies for rounding. 302. That's a 3. 302. 381. 19, I believe was the number. We're going to check this again to make sure I didn't make a mistake. 302, 381, 19. 302, 381, 19. Perfect. That would be the value after 10 years. So you can see buying a home, this is where, just to stop the lesson for a moment, just talk real world. It's very effective. If you can afford a home and if you're planning on living in the city for a while, it's wiser monetarily, speaking of money, to buy a home rather than rent if you can afford to do so, because if you were just renting for 10 years, when you move out, you get 0 money back, or you don't earn any what they call equity of the apartment or the house you're renting. But if you buy a home, even if the bank owns most of the home and you just put down a small portion, as you pay the bank each month, you gain more and more equity. And if the house value does increase, which most do over time, because the number of people increase and land does not increase, it stays the same. Because of that, the house values typically go up and you get to pocket that money. With that, I want to give you DOL part A here, DOL number 4, part A. Here's the word, catch it, depreciate. So first write your equation. You can just pause the video. Okay, picking back up. Hopefully you've written your equation. Now using that equation, solve for part B. What is the value after the boat after 12 years? Again, pause the video and see which answer you come up with. All right, here we go. Example 5. Write a sequence that has 3 geometric means between 264 and 1.03125. Now you might be thinking, what does means mean? The word just means averages. And so really what it's saying is you have the two numbers, 264 and 1.03225. We want to have 3 average values that are averagely separated between these two. Like these two values they gave us are like the bookends, and we have to find the missing values in the middle. To solve this, again, I'm going to use that same formula we've been using all day. AN equals A1 times the ratio, power of n minus 1. Again, that's on your formula chart. That's the nth term for geometric sequences. I want to note that this is A1. And what does that mean for our calculator? If you want to use calculator, is you type that in as AT, the first term. So AT would be 264. And since it's actually the first, T would equal 1. Over here, this we would call, let's see here, it's not the first, second, third, fourth, but the 5th term. So I'd call that a 5. But for the calculator's purposes, we're going to put that in as AN. We have to tell the calculator n equals 5. So that's what we'll do the calculator there. The unknown in this whole mix is, what is my ratio? That is the unknown. So we could do this by hand. I'm gonna, this time, I've done a lot of algebra today, so this time I know some students would prefer, so I'll get the algebra student started. You'd plug that in there, 264 here. To the rate, the power of n. Oh, not n, we know what n is. N is 5, so 5 minus 1. And you'd work through solving this algebraically. You would first, since this is multiplying, you would divide, and so on. You would end up here. Well, I'm gonna leave it there. I'm gonna use the calculator now to find the value. So this stage, I'm gonna switch over. So calculator. Our AT was 264, if I remember right. We'll know if we get bad answers that I messed up. It was the first term, so we leave T as 1. The last term we know is 1.03125. If I got my numbers right, I'm going to check that one. 3.125. Yep. And it was not the 11th term, though. It was the 5th. The ratio is unknown to us. So I'll put an X there. Now I need to zoom in here. And it looks like you look for where all 3 graphs intersect. It appears I might have a problem somewhere. Let me see here. 264, 1.03125. And that's the 5th term. My R is unknown. Well, I'm not sure why these aren't all crossing in this right location here. Okay, that is correct. I'm not sure what's going on with the green lines, why the green lines aren't. I need to check this. I'll have to fix this later. But these are the 2 possible answers, the negative 0.25 and the positive 0.25. There's 2 potential answers. And I'll tell you why that is using the algebra. So here I go saying I wasn't going to do the algebra. I'm going to. 1.03125 divided by 264. Wow, that is a big fraction. 33 over 82. Oh, that needs to be a 4. 1 over 256. I'm going to write it as 1 over 256. 1 over 256 would equal r to the 4th power. The reason there's 2 answers is, if you remember from chapter 2, if you try to get rid of a 4th power, you need to do a 4th root. But anytime you add a root that's even, it comes with a plus or minus. For that reason, the rate is plus or minus 0.25. So now that we know our rate, I'm going to go ahead and circle that, even though that's not part of the answer. That wasn't much of a circle. Let's do this again. Here we go. Now that we know the rate, what we do is we multiply all of these by 0.25, plus or minus 0.25. So that means the next one could be a positive or negative. multiplying by 0.25 is the same thing as dividing by 4. So mental math here. 26 can be divided by 4 6 times. The remainder 2, 2, 4. I'm getting 66 there. I'm going to check that one just because that is a larger number. 264 times 0.25 is 66. And since it's plus or minus that we're multiplying by, this could be a positive or a negative 66. And then I would multiply this times plus or minus 0.25. Plus or minus 0.25. And so again, it's like dividing by 4. This one would not be plus or minus though, just because all negatives, if it was a negative 0.025, it'd be alternating. And so this one would be due to be positive either way. So this one will, no matter what, be a positive number. 66 divided by 4 goes at once, remainder of 26. Ooh, 6.5, 16.5, I think. Should just be using the calculator. Don't want to be messing up. Not 0.25. 16.5, there we go. And one more time. 0.25 is what we're multiplying by. And I'm getting, this would be plus or minus 4 point, I believe that's going to be 125. Let's go ahead and check that. Uh, 16.5 times 0.25. Yes, 4.125. So those would be my values there. Okay, so don't stress on the plus or minus part, but the 66 could be negative as well as the 4.125. But no matter what, the 16.25 will be positive. With that, I'm going to go ahead and erase that plus so it doesn't look weird. No matter what, that would be positive because two negatives, if you were multiplying by a negative 0.25, two negatives would turn positive anyway. So with that, you have DOL number 5. You can go ahead and pause the video. Just remember, when you go to solve this, 20 comma, it says it has 2 geometric means. So just do 2 blanks and then 8.4375. Solve from there and pause the video. All right, I'm going to continue on example 6 here. So finding a sum. So they give some formulas here. I'm not going to actually use that formula. What I'm going to do is use the formula we've been using. The explicit formula, an equals a1 times r to the power of n minus 1. If I'm doing a sum, the only thing I exchange is instead of an equals, I replace that with sigma. A1 times r to the power of n minus 1. And by way of reminder, this n never gets replaced. Like I said in the Bellringer, never replace n inside of sigma. Now I'm going to use the symbols for sigma. That was really ugly. Let me rewrite sigma one more time, a little bit neater. There we go. Never replace that n. So that's how we could find a sum. So let's go through and see our problem, what we got. Looks like they gave me a1. a1 equals 4. For my calculator, if we use that, which I'll show you, that would be at. At would equal 4 and t would equal 1. Okay, I would need to find my ratio. My ratio would equal -6 divided by 4, which that one's a little bit easier to reduce. 2 goes in both these numbers, -3/2 or -1.5. And we're trying to find the sum of the first 11 terms, which let me write this. What we're looking for is what we do is like S11. So here, what I'm going to use is the sum formula. Since I'm looking for 11 terms, whoops, I don't start. The lower bound is not 11. My lower bound is 1. My upper bound will be 11. Or n equals 11. There we go. My first term is 4. We would times that, multiply that with the rate 1.5 and raise it to the power of n minus 1. Right there, if you type that in the calculator, you should get the answer here. Now, that's just if you want to use the calculator, like a blank calculator. That's like the algebra. Now, you could just use my calculator from the get-go. Let me pull that up. We could have said from the start, let me delete this stuff. We said the first term is 4. The last term we do not know, but we do know there needs to be 11 of them. The common ratio we had as -6 divided by 4. And so if you zoomed out here, we just look for where they cross. This would give you the unknown, which happens to be the last term. The last term would be 230.66. But if you want to know the sum, you would look down here. You see both of these are already solving. If it did not show you a number, you would plug in the x value, which in this one it's already solving. It didn't need to know the last term. So it'd be 230.66. On any other scenario where it wasn't showing it, you'd say 230.66, and then it would give you the answer. On this one, the value is 193.996. And what is that as a decimal? Whoa, that's weird. So 139.996 is how I'm going to write that. Again, nearest thousand. 139.996. So about approximately 140. Yeah, approximately 140. That would be my solution there. All right, let's try part B. It says find the sum of the first n terms. So this time I don't know how many terms there are. So this would just be Sn. So n is our unknown of a geometric series with A1. So if you're going to use the calculator, this would be like your AT. AT would equal -4, where T equals 1. AN equals this. And again, for the calculator, we'd have AN equals -65536, but N would be unknown. And obviously our ratio is 2. So we could do the algebra. What's going to be tricky is if you're trying to do the summation, you don't know the N to begin with. You do know the first term. The first term is -4, and you know your ratio. But you'd have to say, what is that value there? And to find that, you would actually need to go through this formula first, just the normal formula. Whoops, that's supposed to be times R. Let me go times. Here you go. A1 times R to the power of n minus 1. You would have to solve this, plugging in your values, where that's -65536 equals A1, we know is -4. That we knew, and we know the ratio as well is 2 to the n minus 1. You'd have to work through and solve that to get your n if you want to do this by algebra alone. But I'm just going to use my calculator. So we know the first term is -4. And it is the first term, so I say t equals 1. We know the last term was -65536. We don't know how many there are. So that's an x. We do know my common ratio is 2. So when I zoom out here, this should tell us that's giving us a negative. We can't have a negative amount of terms. I got a calculator error somewhere in here. Let me see if I typed in something wrong here. Okay, I might have to pause this and fix it real quick. All right, I found my error, fix the calculator. So now I'm coming back. I'm looking for these graphs intersect. And so again, it looks like I'm gonna have to zoom way out. I'm gonna start hitting the minus over there. And I'm looking for the 3 graphs. I saw the blue and the green. They're getting really close to one another. There's the red. And so if I zoom in on this, we should get our answer right there. The answer is 15. That's how the number of terms. So we're supposed to find the sum. That's the number of terms we were missing. If you put a 15 right there for x, it tells you the sum is -131,068. So here, if we would have solved this by hand, we would have found that n equals 15. And so the sum, when you put in a 15 there, let me come back over here. So I now know this is 15. If I plug that in, we would get -131. Was it 086? What was it? 068. 068. 068. That's a big number. Put that comma in there to help us see it. So that would be our sum right there. So sorry about the calculator. I'll have that fixed for you. So when you try it, you won't have to worry about that error. All right, your turn. DOL number 6. Pause the video. Okay, example 7. Let's take a look here. The sum of an infinite series. So here's what I do. If it's infinite, what I do when for the calculator's sake is I just put 1,000. So I substitute, and again, I'll leave this part the same. So what I do is if it's an infinite, I just substitute 1,000. Substitute 1,000 for infinity. So if you ever have to find infinite, that's what I do. Okay, so here it is. If possible, find the sum of the infinite geometric series. So again, I'm going to just use calculator here. That is our A1. A1 equals 24. For the calculator, what does that mean? If I'm going to use my calculator, I'll say AT equals 24 and T equals 1. I don't know the last number, but we do know that N is infinity. We have infinite numbers here. So this one right here, that's saying that N equals infinity, which for our calculator, we're just going to list that. As you guessed it, N equals 1,000 for the calculator. And that leaves us one thing left, the rate. So the common ratio would be 18 divided by 24. I know 6 goes into both those numbers. 6 goes into 18 3 times. It goes into 24 4 times. So 3/4 or 0.75. So if I wanted to find my infinite sum, what I'll type in the calculator from a blank line is I'll type in 1,000 and my A1. Again, I'm using this formula. AN equals A1 times R to the power N minus 1. That's the formula for the formula chart. And all I'm doing is when I plug that in, is I am replacing this with sigma. So now I have A1, which is 24, times my rate, 0.75, to the power of N minus 1. If we type that into the calculator just on a blank line, we should get the solution. And then I'll also show you how for my calculator. So blank line here, let's just do it as if we do this by hand. So SUM, or you can go to functions, miscellaneous, there it is. From 1 to 1,000, the first term was 24, times the ratio of 0.75, raised to the power of, and I need to put this parentheses, N minus 1. N minus 1. And it's saying there's an error here. You can't use N as an index. What's it? Oh, it's talking about this problem. I have an N there. So let me delete that for a second. The answer is 96. So that's what I got first. 96 over here. So we're getting this is equal to 96. Now we'll just use my calculator. If you wanted to use that from the start, we had the first term. The first term was 24. So AT is 24 and T is 1 because it is the first term. We do not know the last term. So that's our X. But we do know we wanted to find, I've forgotten, how many was it? Infinite, 1,000. So I'm going to put 1,000. The common ratio we had was 18 divided by 24. Okay, now I'm going to go home here. Where these graphs intersect should be our answer. Let's see here. Well, it looks like I got all kinds of more math errors to work through on my calculator. Because I'm not getting, we saw the answer should be 96, but it's not coming up there. It is down here though. It's showing 96. That value right there. So the intersection would be the last term. Oh, I know why it's not showing. The last term is 0. That's why. That intersection. Something's wrong with that green line. I'll have to monkey with that later. But the answer here, as you can see, it is 96. So that's correct. All right, part B. If possible, find the sum of this infinite geometric series. Now this one here, this is A1 equals 0.33. For the sake of the calculator, your AT would be 0.33 your t would be 1. We want infinite again, which means n is infinity, is what it truly is. But for the calculator, we would say n is 1,000. And then we need to find the rate. So the rate would be the second term, 0.66, divided by the first term, 0.33, which that's equal to 2. Now here's the deal. This will not have an infinite sum. If your rate is greater than 1, you cannot have an infinite sum. No infinite sum if rate, the common ratio, I should say not the rate, the common ratio, if common ratio greater than 1. Ratio, not ration. Common ratio greater than 1. So it does not exist. Infinite sum does not exist. And that's because the ratio is greater than 1. All right, here's one more. So for our calculator, what we'll type in here is n equals 2 to 1,000 and 3, 0.65. This one, the common ratio is less than 1, so this will exist, the ratio. Oops. The common ratio, 0.65, is less than 1, so it will exist. To the power of n minus 1. And for our calculator, we probably better put parentheses around all that to make sure it's included. Let's see what that ratio is. So I'm just going to get a blank line here. Sum, so functions miscellaneous, where you can type in sum from 2 to 1,000. And put parentheses 3, another parentheses. Let's see here, 0.65, 0.65, all raised to the power of n minus 1. I'll put that in parentheses so it gets it all in there. N minus 1. And again, it's not working because of this n. Let me delete this n down here. Where is it? There it is. I'll delete that just for a moment. So on a blank graph, it would work. The infinite is around 5.57 or 39 over 7. How about that? Let's just write it that way. 39 over 7. This is approximately 39 over 7. Actually, I wouldn't even say approximately. It is equal to 39 over 7. 39 divided by 7. That is my solution there. All right, your turn. Pause the video until you're ready to move on. All right, let's check out our ACP questions. The first one says this: what is the sum of the infinite geometric series? So again, if you're finding a sum of the infinite, you'll substitute 1,000 up here for n. And remember, you start with the formula an, this is all off the formula chart, times a1 times r to the power of n minus 1, and you just remove the an equals. So what I'm going to put in the sigma is this portion right there. So on our problem, let's just see. A1 is negative 9 over 8. So negative 9 divided by 8 times, let's see, the ratio would be 3/4 divided by negative 9 over 8. Let's go figure out what that is. That's an interesting one. So we have 3/4 divided by negative 9 over 8, which is negative 2/3. And you know what, we could have done that because the rule with fractions, when you divide a fraction by a fraction, is you just multiply the denominator's reciprocal. So that would have been equal to 3 over 4 times 8 over negative 9. And so we could have saw that this 3 will go into that 3 times. This will go into that the 8 twice. So 1 times 2 is 2, divided by 1 times negative 3, negative 2/3. That is our ratio right there, negative 2/3. And all this gets raised to the power of n minus 1. Let's go type this in the calculator, see what we come up with. So I want this to be -9 divided by 8. We have -2/3 here. And it looks like it's 19 over 20. 4.45. It's 19 over 20 an option? It is. There it is. You know what? I just realized something. Whoops. To show you my family one more time. When I said the rate had to be less than 1, no infinite sum, if the ratio, I should have said the absolute value of the ratio. So if your ratio was like -2, it still would not have. I put that in the wrong spot. If the common ratio, the absolute value of the common ratio is greater than 1, then you'd have problems. So if it was a -3, you'd have problems. You wouldn't be able to find it. So it has to be a number between -1 and 1 is another way of saying it. Okay, let's look at the last ACP problem. The ball is dropped from a height of 6 feet. Ball drops from a height of 6 feet. Let's say this is 6 feet tall. And the return bounce is 82% of the previous height. So it's going to come up 82%. I don't know what that is. 6 times 0.82. Off the top of my head, 48 plus 12. I want to make sure before I say 4.92. Let's check that. 6 times 82%, 0.82. 4.92, I was right. Should have said it. Okay, it goes up 4.92. Says it has a return bounce at 82% of the previous height. How far does the ball travel when it hits the ground for the 6th time? Okay, this problem's a little tricky because it doesn't just go up 4.92. It's going to turn and go down another 4.92. And then after it hits, it'll bounce up 82%. That's 3 bounces, 4 bounces, 5 bounces, and 6 bounces. And so our height's going to keep getting changed. And so what I'll have to do is add up these values. And so we got 4.92. So then I would take 4.92 and multiply that times 0.82. We'll see what that equals. Enter 4.92 times 0.82 is 4.0344, 4.0344, 4.0344. Did I say that right? Yeah, it is. Okay, and the same thing here. This is going to go up that amount. It's going to go up 4.0344. And it's also going to go down that same amount. So you could just say times 2 there. And to make more space here, let me erase this one. And I'm just going to make them all the same. It goes up 4.292 and down 4.92. So we need to do this a couple more times. 4.0344 times 0.82. And you can see what's happening. Now, if you want to do using sigma, you have to have everything being repeated the exact same. So what would be tricky on sigma is the first fall of 6 feet isn't the same because it's not an up and down, it's just a down. So what I would do is I would calculate the other 5 bounces. Let's call this 1, 2, 3, 4, 5. The number is 4.92 up and 4.92 down. So it'd be like 4.92 times 2. That's the first value. And the ratio is 0.82. Whoops, 0.82 to the power of n minus 1. And we would do that 5 times. Now that would get the 5 ups and downs, but we have that extra 6 feet. And so outside of the parenthesis, where you need to take 6 and add it to that amount right there. And that would give us a total answer from the calculator, which is probably the quickest way of doing this. Let's go to the calculator and try this out. So 6 plus the sigma 1 to 5, because we have 5 full bounces that go up and down. Come on. 5. That first one was, we said 4.92. 4.92, but it's going up and down that amount, so I double it. And then my ratio is 0.82. Whoops. 0.82. I wanted that in parentheses. Raised to the power of n minus 1. I need to use parentheses n minus 1. And it looks like the answer is about 68.3989. 68.389 approximately. 68.389. Says, how far has the ball traveled when it hits the ground for the 6th time? Round your answer to the nearest 10th of a foot. So we would actually round that to its 10th. It has 10, 1, 0, so it'd be 68.4. 68.4 feet would be your solution there. And to make sure I was clear, the reason I did not put the 6 in is because originally that 4 point, the 6 just fell. It didn't go up 6 and down 6. And so I just said these ones were repeating. These were repeating. And so the repeating part I put in the sums, and then I just added 6 to it on its own. So I think if I did everything correctly, that should have been the right number. We had 5 bounces. It went 4.92 up and 4.292 down. Times 0.82. Oh, I have an n minus 4. That was one mistake, though. It should be n minus 1. Some of you might have been going, what? It's actually 40.3995. Okay, let's just say 40.4. So I'm glad I went back to that. It is not that number. It is 40.4 roughly when we round this. 40.4. So the 0.4 worked out, but it wasn't 6.8. 40. There you go. And that's a wrap.